Low water fuel cutoff operation. Low water fuel cutoff designs vary, but all low water fuel cutoffs have the same purpose. The burner continues to fire while the water level in the boiler is at the normal operating water level. If the water level drops to an unsafe level, the float or sensor in the low water fuel cutoff opens the electric circuit to shut the burner off. The burner shuts off to prevent damage to the boiler from overheating. The water is still visible in the gauge glass when the burner shuts off. A float type low water fuel cutoff consists of a bowl mounted at the minimum water level in the boiler, and the float is connected to a lever that actuates a switch when the float drops below the minimum water level. The switch deactivates the control circuit that allows the fuel to flow. A low water fuel cutoff must shut down a boiler in the event of low water. Boiler overheating due to low water is a common cause of damage. Water must not be added to the boiler during low water conditions. It can cause a boiler explosion when feed water touches the hot surface and flashes to steam. A probe-like low water fuel cutoff performs the same function, except the probe uses the conductivity of the water to complete the burner control circuit. The metal probes vary in length and are suspended in a sleeve or a chamber. Current flows through the boiler, water in the chamber to complete a circuit. When the water level in the boiler drops below the end of the probe, the circuit is opened and the burner control relay is de-energized. In a high water condition, a different circuit is energized. In a probe type low water fuel cutoff, there are no moving parts within the probe chamber. A displacer type low water fuel cutoff consists of a cylindrical object that is immersed in the water and connected to a spring or torsion device that twists in response to the weight of the cylinder. The weight changes according to the amount of the cylinder immersed in the water. The displacer is usually mounted in a housing called a cage that eliminates fluid turbulence. A rod running down the center of the torsion tube transfers the amount of rotation at the sealed end of the torque tube to the various output devices. An output device can be a pneumatic transmitter, a pneumatic controller, or a 4MA to 20MA transmitter. Low water fuel cutoff testing. Low water fuel cutoff controls are tested by blowing down the control or by performing an evaporation test. The simplest method is to blow down the controls daily or more often. This removes most accumulated sediment and sludge. However, this is not representative of normal operation where the water level in a boiler drops slowly. Therefore, an evaporation test needs to be performed at least every 30 days. Water level measurement. An important step in controlling the water level in a boiler is to measure the water level. A water column is used to minimize movement of the water surfaces to make it easier to measure. There are several types of instruments used to measure the water level. Alarms are often included in water level measurement systems. Water columns. A water column is a boiler fitting that reduces the turbulence of a boiler water to provide an accurate water level in the gauge glass. The water column also serves as a fitting to which the following may be attached: gauge glass, tricocks, high and low water alarms, and gauge glass and water column blowdown lines. Some water columns have pump controls and low water fuel cutoffs attached. Water columns are made of cast iron, malleable iron, or steel. Cast iron can be used for pressures up to 250 psi, malleable iron for pressures up and including 350 psi, and steel for pressures higher than 350 psi. The water column location. The water column is connected to the highest part of the steam space and to the water side of the boiler. The connecting pipe size must be a minimum of 1 inch and must meet the requirements of the ASME code for both pressure and temperature. Provisions must be made for cleaning and inspection by installing cross T's in pipe connections. The location of the water column differs slightly in fire tube and water tube boilers. On fire tube boilers, it is located so that the lowest visible part of the gauge glass is 2 to 3 inches above the top of the tubes On water tube boilers, the water column is located so that the lowest visible part of the gauge glass is 2 inches above the lowest permissible water level as specified by the manufacturer. The position of the steam and water connection for a water column is specified in the ASME code. Valves. Valves are permitted between the water column and boiler if they are as specified in the ASME code. The valves must either have outside stem and yoke, OS and Y, valves, or stopcocks with levers permanently fastened. Both types of valves are to be sealed or locked in an open position. Some state and local codes do not allow any valves installed between the water column and the boiler. The appropriate code should always be checked for valve installation requirements. Lines cannot connect to the water column that would cause a flow of steam or water because this would result in a false water level reading.